The focus of today's lesson is to continue working with user-defined data types and learn how to define the composite types, which include records, sets, and classes and objects. You should then be able to choose and design an appropriate user-defined data type for any given problem. Now, before we begin, let's do a slight prior knowledge check. From the previous lesson, you should already know about some of these questions. Pause the video and go through these. Do you know what data type references memory locations? Can you give an example of a non-composite data type? Which data type is similar to an ordered list? And how can an enumerated data type be implemented in Python? Now, the last one might be a bit tricky depending on which programming language you've chosen to work with. So if you're using Java or Visual Basic, you might want to look into how enumerated data types can be implemented in those languages. But for us, we're going to be using Python as a base, and you should know how an enumerated data type can be implemented in Python. So hopefully you paused the video and you've thought about these and you worked out that the data type that references memory locations is a pointer. An example of a non-composite data type could be either a pointer or enumerated. Which data type is similar to an ordered list? That's obviously enumerated because everything is in an implied order. And finally, you should know how enumerated is actually defined in Python. So for example, you import the enum library routine into Python from enum import enum, then you set up a class to store the ordinals of the similar data types, and then you can actually output them, or you can question at which position a particular ordinal is stored in. So do pause the video and have a look at the Python code on screen. Hopefully you got something similar. So let's move on to today's topic. We're still with user-defined data types, but we're going to be looking at the definition and use of composite data types today. We're going to be looking in particular at records, sets, and classes and objects. So let's start with the record data type. Now, a record user-defined data type is the most useful and therefore the most widely used. It allows the programmer to collect together values with different data types, and these are grouped together to form a coherent whole. Now, for example, think about the inventory system we were talking about in the previous lesson. You might have the name of the item, which is particularly string. You might have the price, which could be a real. You might have the quantity of the item, which could be an integer. And all of these are grouped together into a record data type, which is called inventory. Now think about this. Is this going to be a composite or a non-composite data type? Hopefully you picked composite because it's a compound or collection of multiple different base data types or primitive data types. So how do we define this in pseudocode? Well, we start with our good old friend type, which basically informs that we're about to create a new user-defined data type, and we're going to call it whatever we want to. In this case, let's create a student record. So we're going to call it tStudentRecord. Now we're going to declare within this student record the first name, which is going to be string, the last name, which is also going to be string. We're going to declare absences, which is going to be integer, and we're going to declare class, which is going to be string. And then once we're finished with all these variable declarations inside this record, we then simply type nType, and that simply says that the record data type is now complete. Now, how do we use it? Well, we use it exactly like any other data type. Once we've defined the record data type, we're simply going to declare a new variable. In this case, on screen you see student1, and we're going to define it as tStudentRecord because that's the new data type that we've created, just like how you would use an integer or a string. So how do we go about changing the individual variables inside this particular data type? Well, we're going to now say student1 dot first name is assigned the value John, and student1 dot last name is assigned the value Doe, and similarly absences and the class is actually assigned a value. And often multiple pointers are needed to construct records because each of these variables are going to be stored at a particular memory location. And Python is pretty cool, and it probably takes care of all of this behind the scenes. But if you're using JavaScript or Visual Basic, you might need to define the different pointers that then access all of these values. Okay, so that was the record data type. Let's look at the set data type. Now, set data type allows a programmer to apply set theory operations to data in a program. And if you know a bit of mathematics and statistics, you know that set theory is pretty powerful to find out patterns and allows you to join two different sets of data and work out which one intersects, which one is the different set of values, and all of the rest. I'm not going to go into that level of mathematics here, but if you're not sure about how the set maths works, maybe just have a look on YouTube or on the World Wide Web and then find a website that teaches you about sets. Now, we are just going to be talking about how the set data type actually works. Sets, in particular, cannot have data items repeated more than once. So, for example, you might have one set which has all unique values. So kind of like an enumerated list. Now, what if you have multiple enumerated lists and you wanted to find out which one of these values are unique and which ones are being duplicated in these different enumerated lists? That's where you could probably come up with set theory to find out the answers to that. So you need to make sure that the typical set operations like union, difference, intersection, including an element, excluding an element, and checking whether an element is in a particular set are typical operations that you might need to conduct. And of course, this needs to be done in the programming language. So make sure that whichever programming language you're using, you can find out exactly how to use sets. Now on screen, you will see a bit of Python code that allows you to play along with sets. So do pause the video and just study this. Read the comments, and that will probably make it pretty clear on how sets work in Python. Okay, so how do you add a value? How do you update a value to a particular set? How do you print out the values that are in a particular set? How do you remove an item or discard it? All of that is there in front of you. The next image that you see is how do you use the typical set functions in Python, like union and so forth. So do pause the video and go to this image as well and try to code these in Python. Try to also read the comments and try those things. Sometimes there is a little activity. Now, if you were in my particular lesson, we would probably be doing this live, and that way you could experiment with this and see what goes wrong and what errors can be made when we're operating with sets. Right, so let's move on from sets to classes and objects. Now, this is one of the most fundamental programming techniques that you'll be using as you develop your programming skills and work in industry. Classes and objects often tend to be the baseline. We tend to use records quite often, but classes and objects are perhaps the most popular form of creating user-defined data types or data structures. So what is the difference between a class and an object? Let's start with that. A class is a template which cannot be executed. So it's kind of like that abstract schema that you create in perhaps databases, and an object is an instance of a class which can be executed. So we create this template, and the template just exists until we create an object, and the object is where we do our operations or execution or functions. All of those run on that particular object. So the class is a blueprint, and the object is obviously what you make from that blueprint. Now, one class or one template or one blueprint can be used to make many objects. And that gives us that particular flexibility once again, that you can modify the class and it applies to all of the objects that have been created based on that class. So you can enhance the functionality of a particular class over time. Now, what are the main components of a class? So when we're defining this blueprint, we're going to use attributes and methods. Okay, and we're going to be looking at that in a moment. And what's the difference between a structure, such as a record, and a class? Well, records and structures do not have any methods. For example, The record data type will just store the attributes or the variables or the fields, whatever you want to call them. So these attributes, a record type will just store data about those. Whereas in a class, we can have functions and methods that can apply to that data as well. So it becomes a complete package. So we can create custom methods that apply to a particular class. For example, if you had a class for a car, you might have a method that allows you to work out, what the fuel efficiency of that car is. And this is available for every car that you might actually create based on that blueprint. And again, we'll look at that if it's a bit confusing right now. So what about objects? An object data type is a composite data type used in object-oriented programming. Essentially, objects are just records with functions that act on the data that they contain. That's all there is to it. So you have a class, you make an object, and it'll have some functions or methods that can be applied to it. Whereas a record is a composite data type which just has data in it. So more or less, objects and records are the same thing. Just objects have some special functions that you can apply to it or some special methods that have been written to make use of that particular data. So let's look at how this works in practice. So a car could be represented by a car object. The data or the attributes might include color, fuel, manufacturer, the max speed of a car perhaps, and the methods or the procedures that you will write eventually might include starting the engine, acceleration, brake, refueling, set speed, because all of these methods will do some type of calculation based on what data is contained in the object. So the class is the blueprint which will contain the attributes and the methods, and every time we want to make a new car, for example a Tesla, we would use this blueprint because a car will have a color, a fuel, manufacturer, it might have doors, engine, all sorts of things there, which are going to be same for all cars. So they're all going to be part of the same class. Attributes and methods are part of the class blueprint. You create an object, and the functions that you might then apply on the object is get the fuel, get the speed of the car at the moment. So it can then use that to return a value back, and then you find out what the current speed of the car is or how much fuel is remaining. Now, objects do not exist in source code. You cannot directly write down an object. Instead, you must create an object piece by piece, filling in the individual bits of data and code. So think about how we did the record data type. We had to assign each individual attribute a particular value. That's exactly what happens with objects as well. So on screen, you will see a bit of Python code. So go through the comments. As usual, pause the video, look through how a class is created, look through how the definitions work for that particular class. Here's that hypothetical car that we were talking about. We created a class for the car, which has a color, a mileage, whether it's automatic, and then we can define the actual objects, which is car1 and car2, which use the car class, and then defines those attributes across. And then we can work out the individual methods or functions. Car2, in this case, we don't have any particular methods defined in the class, but we certainly could if we so wanted to. If you wanted to learn more about classes, there's a website link that you can see towards the bottom of the image. Make sure that you follow that. But again, there are multiple videos on YouTube and online, so you can use those as well. We're probably going to be looking at classes, objects, and all of these in due course when we look at Python in a bit more detail in one of the later lessons. So for now, we're just going to come back to why do we need user-defined data types. And as we already know, the three main reasons for encapsulation, reliability, flexibility. But for any reasonably large program, it is likely that their use will make a program more understandable and less error-prone. Because once a programmer has decided, because of this particular advantage, to use a data type that is not one of those built-in ones, then user definition is inevitable. Whenever you want to model something in the real world, you might need to use a combination of base or primitive data types like real, integer, string, boolean, and so forth to create the model that you want to create of the real world. So the use of, for example, an integer variable is the same for any program. However, there cannot be a built-in record type or a built-in class that is universal, because each programmer might have a different need for that record or that different need for that class. Therefore, there is a need for user-defined data types, and that's where all of these come in handy. They give you that flexibility to become creative and create your own models of the real world. Okay, great. So we know now about composite data types. The final part of user-defined data types states that you need to be able to choose and design an appropriate user-defined data type for a given problem. So let's look at how all of this can be put together in the form of some questions. So on screen, you see the first one, an example which states that you need to create an enumerated data type for days of the week. You then need to declare two variables, today and yesterday, using that new data type you've created. And you need to assign a value of Wednesday to today and write a suitable assignment statement for tomorrow. Okay? Pause the video, have a go at this. Okay, let's look at the solution. Well, hopefully you got something similar. You got a type, T days, and then you would have the days of the week, Monday, Tuesday, Wednesday, and all the way down to Sunday. Then you might have declared today as the new data type T days, declare yesterday as T days as well. You assign the value Wednesday to today, and tomorrow is basically today plus 1, because remember, enumerated is an implied order of ordinals or values, and then if you have one day, you can just use plus 1 or minus 1 to subtract and so forth. So you should have something along the lines of this. Okay, let's look at example number 2. Create an enumerated data type for months of the year, declare a variable this month, and declare a suitable pointer, and set your pointer to this month. Okay, so there's a couple of things going on. We're going to now use two user-defined data types, enumerated and pointers. So do pause the video and think about how you're going to be solving this one. Okay, so hopefully you got something similar to this. You once again did type T month and had all your months there. Then you declared this month as the data type T month. Then you assigned the value to this month as September. So that was the first part done. Then you created a new type called T month pointer, which was given the data type of T month. And then you declared the month pointer with the data type of T month pointer, which is the new pointer we just made. And then the month pointer variable is assigned the value to this month, which is September. Now let's look at the next example. Create a record data type for a book database, and you can choose whatever attributes you want in this particular one. I'll just give you an example in a moment, which might be a bit different from the one you came up with, but the overall structure should be similar. So pause the video and think about this one. Okay, so you should have a type, once again, because you're creating a custom type. In this case, we're going to call it T-book record. You might have called it whatever you want. And you would then declare a few attributes like title, author, publisher, genre, price, with the appropriate base data types like strings and real in this case. You might have different ones there. But remember, you should always end the record type that you're creating with end type. Now, you don't need to do this for enumerated. You don't need to do this for pointer, but you need to definitely do this for record. So when you try to create a record data type in pseudocode, you write type at the top and end type at the end of that. Just like when you would do that procedure and end procedure, function and end function, you've got to do the same thing for the record data type. Okay, we're going to stop here for today. On screen, you see a few questions which are going to utilize the knowledge that you gained in the previous lesson and today's lesson about non-composite and composite data types. And you should be able to answer all of these questions pretty easily. If you do struggle, do let me know. Think of this as a bit of homework for you to just practice what you've learned so far, because just listening to videos doesn't give you that knowledge. You will need to make notes. You need to make sure that you're doing a bit of writing and you're applying that knowledge in practical exam type questions, and here are a few of those. So pause the video and perhaps go through these. Okay, that brings us to the end of today's lesson. Hopefully you can give examples of composite data types and what the need for user-defined data types is. You should be able to define the record data type. You should also know how a set data type works in Python in particular, and how classes and objects operate. I'll leave it here for today, and I'll see you in the next lesson.